In this video, I want to talk about a very simple yet very fundamentally important property in SQL that we tend to forget and overlook in our day-to-day queries. So I want to do this through a LeetCode problem called second highest salary, and I'm sure this is a very famous interview question that you would run into if you were preparing for any SQL interviews. So here we have an employee table with two columns, ID and salary, and all we have to do is find the second highest salary, right? So ID is the primary key and salary is the corresponding salary of that employee. And the catch here, I would say, is that if there is no second highest salary at all in that table, we have to return null, right? That means that we can't return an empty data set. We have to return exactly one row with null in it. So we have to return a null record. Let's just get into the solution a bit later after these two examples. So here we have a very simple example with three salaries and 200 the second highest salary. That is what we're displaying here. And in this second example, this is kind of an edge case where we have the same salary. So there is no second highest salary as such in the table, and the output should be null, right? So this is the problem description, and I just want to get into the problem directly on LeetCode and start solving it step by step and sort of discover the point that I was talking about. So guys, here I am on LeetCode and we have the same example on the left over here. So let's just start kind of freestyling the query. So since we have the highest, second highest something, so obviously we need to order by that column and it should be order by descending, right? So let's just try to write a simple query. Select salary as whatever we need the output to be from employee, order by salary descending, right? So this would give the entire table ordered by salary descending, but we want just one row, which is the second highest column, right? Second highest salary. So we could limit one, but skip the first record using offset, right? So if we do this, definitely it should give us the second highest salary, but there is a catch, right? If you have two people with the same salary as the first highest salary, let's say ID1 and ID2 here had 100 and 100, then even when you order by salary descending, the second row would be still 100, giving you the first highest salary, right? So we need distinct salaries, so we could just put distinct before salary over here. So this looks like it should work, right? Let's just try running it. Okay, here we see that there's one case that's right and the second case is failed. The first case was this simple example and the first input has passed, but the second input, right, where there's only one salary and there is no second highest salary, the catch that I was talking about, right? So here if you see, we have returned no records at all, but the expected result was one record with null in it, aka a null record. So this is the main catch that I want to kind of discuss in this video. This is probably the reason I kind of made this video. So if you go through the discussions of this problem, a lot of people have the same question regarding how to get the null record, the single null record as the result, and not an empty data set. So this is the trick that I want to talk about, and it's a fundamental SQL property that I want to get into. So let me just show you the solution directly, and then I want to get into kind of that SQL property that I'm talking about, right? So all we have to do is just put the original query that we wrote in another select statement, right? As simple as that. We're just selecting this as an inner query, right? I'm running it now, and you would see that this would pass the second result as well, second test case as well, right? So if you can see here, we are getting null record as the result. So this kind of seems weird, right? So why is this happening? What does one select do on top of the inner query? So let me submit the solution right now and see if it passes all test cases. So it does. Let's get into why this is actually happening. Let's just try to understand and break down what's going on here. When you run a query, the result is a table, even if that table has no rows. And in the case of a subquery that returns 0 rows, the result is still considered a table with a specific set of columns, but with no actual rows of data. And when you perform a select on top of this subquery, SQL kind of expects a result set with a specific structure and a certain number of rows. And since the subquery produced an empty table with no rows, SQL will still generate a result set with one row filled with null values to match the expected structure. So here, if you see this simple example to illustrate, if the subquery here returns 0 rows, the outer query here would still produce a result set with the same number of columns as the inner subquery, but with one row filled with null values. This is exactly what we needed. Now, the exact behavior, of course, depends on the database system, but this is a standard behavior that we see across most databases. So, this design choice means that when the subquery is run alone or run independently, it represents a virtual table with columns but no rows. But when it's run in a larger query as a subquery, the outer query expects a result set with a specific structure, including a row as well, even though the subquery didn't have a row. So, this is why we see this behavior with subqueries. And this design choice simplifies the handling of the result set, right? And it makes queries more predictable and consistent. Now, I did try to find some official documentation for this, but then I couldn't really find it, and maybe that's because the documentation is specific to that database system, like Oracle or MySQL or PostgreSQL. So maybe there is some documentation that actually mentions this somewhere, or it's just a design choice that is not available as documentation. But let me know in the comments if you have any information on that. So anyway, thank you guys for watching this video. I hope it provided some value, and I'm sure more of the advanced and intermediate, I would say, data analysts or engineers or scientists would know this, but for beginners, I hope this was of good value. If you like this video, please consider subscribing and giving me a like and doing all the YouTube stuff. I would love to do more such videos about interesting stuff that I kind of discover in my day-to-day job as a data engineer and kind of share it in this format.